Hello and welcome to Train Signal. You're watching A+ Essentials Personal Computers Part 2. This is part of Train Signal Fast Track CBT video CompTIA A+. In this video, our overall goal is to help you understand the fundamentals of personal computers. This is a continuation of our Part 1 video covering personal computers. And in this video, we'll go more into depth in the topics of processors, memory, display devices, input devices, adapter cards, ports and cables, cooling, and then we'll learn the basics of installing, removing, configuring displays, storage, and simple input devices on our computer here in our Train Signal lab. Alright, in this video, as far as A+ Essentials topics that we're covering, we're going to continue covering A+ Domain 1.1, which is identify the fundamental principles of using personal computers. There's a lot of topics in this domain, and it's very important that we cover all the relevant topics. So, first off, we'll talk about the names, purposes, and characteristics of processors, CPUs, different brands of chips, technologies, hyper-threading, throttling, caching, speed, 32-bit versus 64-bit. We'll learn the names, purposes, and characteristics of memory, different types of memory, different types of video connectors and display devices. We'll talk about biometric devices and touchscreen, different types of input devices, different types of adapter cards. Let's see, we'll go on and we'll learn about cooling systems, FireWire, USB. Then we'll move on into our hands-on part of this video where we'll learn how to add and remove storage devices and configure display devices and input devices. So with that, let's get started. And first off, we'll talk about processors, also known as CPUs or central processing units. These CPUs are the heart of the computer. CPUs are made up of millions of tiny transistors. CPUs are located on the system board and are either in a socket or a slot. Now, the CPU controls all processing of the computer, and it performs all communication necessary between the CPU, memory, adapters, and storage through the system bus and through the logic controller on the motherboard. Now, Intel and AMD are the two primary manufacturers of PC CPUs in the world. Each manufacturer periodically releases new processors, and their processor lineups are typically arranged into notebook processors, desktop processors, and server processors. For example, the Intel processor lineup can be found at this URL right here. Alright, so I'm going to click on this link. And if we scroll down, you can see that their processor lineup is arranged in desktop, laptop, server and workstation, and embedded processors. So if I click on the desktop, we can scroll down and you can see here that they have this Intel Core 2 quad processor. Q6600 is their featured product. They also have the Intel Core 2 Extreme and the Intel Core 2 Duo processor. So if I click on the Core 2 quad, this is one of the most powerful processors that Intel makes. It's like having four individual CPUs inside one CPU. And it says 4 processing cores, up to 8 megabyte of shared level 2 cache, and up to 1066 megahertz on the front side bus. Really amazing speed that they're offering. So let's go back. And so we talked just a little bit about processors. Let's move on and talk about CPU technologies that go inside these processors. So the first one is hyper-threading. Now, Intel has a hyper-threading technology called HTT, and it's a type of simultaneous multithreading, or SMT. Now, by using the superscalar technology of certain CPUs, you can perform multiple operations on the same processor at the same time. Now, to the operating system, the computer appears to have 2 CPUs when hyper-threading is enabled. Now, this has nothing to do with cores, multi-cores. We're going to talk about that next. Hyper-threading is a technology of the processor that allows the operating system to believe that the processor has 2 individual processors in it, or the system has two processors, and the processor can actually do two things at the same time. So it's pretty amazing. Multi-core is actually much better though. So then there's multi-core. Multi-core is where you can have dual core or quad core, and we just looked at that Intel quad core. Uh, this is essentially 2 or 4 CPUs inside one CPU. Really amazing technology, and it makes your system very fast. All right, the next one is throttling. This is also called clamping, and this is what controls how much time a CPU spends on a single process in an attempt to treat all processes fairly. So that's throttling. It's there to make sure things are fair. Just try to remember that. All right, then there's microcode. Microcode, also called Multimedia Extension Microcode, or MMX, is a type of coprocessor for a processor. MMX microcode is incorporated into most modern processors. So MMX is there to help with multimedia tasks. Then there's overclocking. Now, overclocking is when you modify the speed of your processor yourself in an attempt to increase performance. Now, this can also increase heat from the processor tremendously, and it can cause your processor just to melt, literally. So overclocking isn't something that a CPU manufacturer created. In fact, they don't want you to do overclocking because you're going against their recommendations for the speed of the processor. But overclocking is something that people who are really into CPUs and getting the most out of their CPU do sometimes to try to increase the performance. But like I said, it can also damage your CPU and cause you to have to replace it and get a new CPU. So then there's cache. Cache is very fast and specialized memory used to hold data for the CPU. Now, level 1 cache, or L1 cache, is inside the CPU. Level 2 cache, or L2 cache, is outside the CPU. Cache is for information that the CPU uses frequently. Now, by having access to it, performance is increased. So think of this as super fast memory that the processor can very quickly reference and get something out of that it was using. So I think of this as short-term memory, for your brain. Then you have a little bit longer-term memory, which is like your regular RAM, and then you have very long-term memory, which would be your storage device, like your hard drive. So it goes cache, RAM, then storage or hard drive. All right, another CPU technology or just something that you need to be aware of and how it helps the CPU is the voltage regulator module, or the VRM. This regulates the voltage to the CPU. The CPU is very sensitive to power spikes, so it needs this voltage regulator to regulate the voltage and provide it a steady stream of power. Then there's the speed of the CPU. You have to keep in mind the real speed of the CPU versus the actual or the published speed of the CPU. Now, the speed of a processor is shown in gigahertz or megahertz if it's a slower processor. Today, processors are in the gigahertz range, say 2 or 3 or more gigahertz. Now, the advertised speed may be different because the CPU can split the clocking cycle. So just because a processor says it's this one's 3 gigahertz and that one's 3.5 gigahertz, well, you would think that the 3.5 is faster, and usually it is, but you really have to look closely at the speed benchmarks of these processors. You have to do some research to really find out exactly which one's faster, because there's so many different technologies now that make these CPUs faster or slower. So the 3 gigahertz processor might have quad core, let's say, and by having quad core, it's like having 4 processors in there. Or maybe it has 4 megs of external level 2 cache, and the 3.5 gigahertz only has 1 meg of level 2 cache. And by having the extra cache, even though the 3 gigahertz processor is slower, it actually does things faster. So you have to keep these things in mind when you're comparing processors. All right, then there's 32-bit versus 64-bit. Now, many of the new processors have a 64-bit bus. This increases the performance of the processor, and performance is especially increased when you have a 64-bit operating system to go along with it. So you can get 64-bit Windows XP, 64-bit Windows Vista, 64-bit Windows 2003 server, and then you have to, or commonly, you need to get 64-bit applications to go inside those operating systems. They are also backward compatible to run many 32-bit applications, but not all. So you could have a problem by having the 64-bit operating system. Perhaps you can't run the game or whatever it is that you wanted to run or that you have run in the past. But you will get a heck of a lot more performance out of a 64-bit processor, especially when you have a 64-bit operating system. All right, now let's talk about memory. Now, just like a human, RAM, the memory for a computer, can make mistakes and lose data. Can you believe it? A computer made a mistake. Well, actually, what it is some sort of malfunction with the RAM, or a short connection, loose connection, or some sort of problem with the RAM that caused it to lose the data. Now, to check up on your RAM and make sure that nothing is lost, there's a numerical calculation performed in RAM called parity. Now, the problem with parity is that it can tell you your RAM made a mistake, but it can't fix it. So when you have a mistake made on the RAM, but it's not resolved, typically what happens is your computer crashes. Your computer crashes. You get a blue screen. The blue screen of death, they call it. Now, to resolve this, there's something called ECC, or error checking and correcting. The correcting part is important. Now, when most people talk about RAM, they're talking about DRAM, or dynamic random access memory. The dynamic part just means that the memory constantly needs refreshing or updating. So the different types of RAM are listed here. There's SDRAM, or synchronous DRAM. This is old technology, not used really today. There's DDR-RAM, which is double data rate. It doubles the speed of the SDRAM. Then there's DDR2. This is double data rate times 2, or double the speed of DDR. This is what's used today, but DDR3 is expected to be out sometime in 2007. Then there's RDRAM, or RAM Bus Direct RAM. This is proprietary SDRAM, and it's used less and less today. Then there's SRAM, or static RAM. This doesn't require a refresh like SDRAM does, but it's much faster than SRAM, or much faster than SDRAM, but more expensive. And often, SRAM is used for cache memory. So that level 2 cache we were talking about is commonly SRAM, or static RAM, because it's much faster than the SDRAM. All right, so those are the different types of RAM. So most likely today, if you're going to go out and upgrade your new PC with some new RAM, you're going to buy DDR2 RAM, or maybe even DDR3 RAM if that's out and it's available for your PC. All right, a little bit more on memory. First off, there's ROM. ROM is different from RAM in the sense that ROM is read-only memory. Now with ROM, the data is written but cannot be changed once it's written. BIOS is stored in ROM. So ROM is not very commonly used, but it's used for BIOS in every single computer. But once you have your computer, you're not really using ROM for anything. RAM is really where all the focus is. But it's important to know what ROM is. Now RAM, on the other hand, can be packaged in either DIMM, RIM, SODIMM, or microDIMM. Now we talked about things like DDR, and those are the type of RAM, but then you have the form factor, or the size of the RAM, and the type of slot that it goes in. So they can take that DDR RAM and they can create it into different size chips. So for example, in a laptop or an integrated computer like an iMac, you might use a SODIMM or a microDIMM. These are much smaller, more compact forms of RAM. Now you can obtain DIMM chips that are either single-sided or double-sided. So RAM can many times be on both sides of the chip. So now let's talk about how this computer storage, such as RAM or storage on your hard drive or your USB thumb drive, how do you measure that storage? Well, storage is measured in bits, bytes, kilobytes, megabytes, gigabytes, and terabytes. So a bit is the smallest form of storage on a computer, and a bit is either a 1 or a 0. So a bit is either on or off. Now a byte is 8 bits, And keep in mind that everything in a computer is processed and stored in bits. So no matter if you're looking at a graphic, a video, a word processing document, or some program or a game you just downloaded, to the computer it's all bits. It's all either ones or zeros, no matter what it is. So these ones and these zeros are, clumped together into a byte, which is 8 bits. Then there's a kilobyte, which is 1,024 bits. A megabyte is 1,048,576 bits, and a gigabyte is, let's see, 1,073,741,824 bytes. Now this system can just keep on going on and on. So above a gigabyte, there's terabytes, there's petabytes, there's exabytes, zettabytes, and yottabytes. Now today there's nothing that holds a yottabyte, and most people don't even know what it is. But terabytes to me is sort of the largest single storage measure that people commonly talk about. In a data center, let's say you might have 10 terabytes of data stored for a billion-dollar company that has all this data that they've been keeping for years, including their email and their files. You might have 10 terabytes, let's say, of data. But commonly at home, people measure storage in gigabytes. So, they might say my hard drive has 80 gigabytes of storage, or my RAM in my computer has 2 gigabytes of storage. Or I just went out and bought a 4 gigabyte iPod. These are all just examples of measuring storage. And it's very important to understand these measures of storage. So for example, say you create a 100 megabyte file. Can I put that on my 1 gigabyte flash drive? Well, absolutely. Yes, you could put 10 100 megabyte files approximately on a 1 gigabyte flash drive. But what if I take a 4 gigabyte DVD file? Can I store that on my 1 gigabyte flash drive? No, you cannot. Could I store a 4 gigabyte DVD file on a terabyte of storage? Absolutely. Let's see, one more example. Can I take a 20 megabyte email and email it over my 1.5 megabit DSL line? Well, sure you can, but it's going to take some time to transfer it. So these are just all examples of understanding these different measures of computer storage. So I encourage you to spend some time getting familiar with these measures of computer storage. There's a link here to the Wikipedia, which goes into more detail on these different types of measurements. All right, so now let's look at some RAM photos. I just want to remind you what RAM looks like. So here's a motherboard. Here you've got your RAM chip. You see these sockets that they fit into. You can have different size sockets. These are single-sided chips. You see the RAM on one side of the chip. Here's another RAM chip. You see it says 512 megabytes, so that's how much storage is on this chip. This is DDR RAM, and this is also a DIMM chip. This is the format of the chip is a DIMM. The type of RAM is DDR, and it's 512 megabytes. You see up here, this is DDR 333. 333, that's the speed of the RAM. RAM also has a speed measurement. Besides having a size measurement, you have a measurement of speed of how fast is this RAM. So you want to make sure that the speed of your RAM matches the speed of your RAM sockets to get the best performance. If you put slower RAM in there, it'll still work, but it'll slow down your computer. So make sure your RAM is at least as fast as the speed of your bus of your RAM sockets. All right, this is just the back of a RAM chip that's not double-sided. And so those are our pictures of RAM. All right, now let's move on and talk about display devices. All right, computer displays are called monitors. That's typically what people call any type of computer display, a monitor. Hey, I need to upgrade my monitor because it's kind of flickering, or it's too small. I want a bigger monitor. Technically, people have called them VDUs, or video display units, but I rarely hear anyone ever say that. Monitors convert the computer signals into the graphics you're used to seeing on the screen. Now, originally PCs used TVs, like a TV set, but TVs don't have high enough resolution to show the graphics that were required. TV sets actually are low resolution devices compared to computer monitors. Now, new high definition TV sets are actually as good or much better than a computer monitor. Now, inside the computer, there's a video graphics adapter called a video card, and I'm going to show you a picture of a video card in a second. This video card has a certain type of output, a certain type of cable that's used to connect to your monitor. So you have to make sure that the adapter cable from your monitor will plug in to your video card. Sometimes those video cards are integrated into the motherboard, sometimes they're a separate card. Now, there's different types of monitors. In the past, people used CRT monitors or cathode ray tubes. Those are the common monitors. This is an example here of a CRT monitor. You see how it has this big back? That's the tube that makes the signal on the monitor or the display on the monitor function. These can get heavier and heavier as they get larger, and they're bulky. They're very bulky, large computer displays. Now today, LCD displays or liquid crystal display monitors have taken the market over. LCDs are much smaller, much more lighter, and the price has gone down to the point that people just aren't selling CRT monitors anymore. They're selling LCD monitors. LCD monitors are really the way to go today. So up here you see an example of an LCD monitor. This screen is only about an inch or 2 inches thick, much lighter, much larger display typically, and for the same price or less than CRTs we're going for. All right, let's talk a little bit more about display devices. The quality of your video display system, and when I say video display system, I mean the video card and the monitor combined, is measured in resolution and number of colors. That's very important. You measure your video display system in resolution and number of colors. So an example of resolution is 1024 by 768. This is the resolution, the number of lines of screen on your screen horizontally and vertically. Now, a pixel is the smallest dot that makes up the image on the screen. So these are tiny little dots that make up everything you see on the screen. So there's hundreds or thousands of pixels on your screen. Now, with 1024 by 768 resolution, there are 1024 pixels across and 768 pixels down. That's a lot of pixels. Now, the more resolution you have on your monitor, the finer the picture you have. So the higher these numbers are, the finer the quality of the picture on your screen. However, text and graphics will also appear smaller. So unless you get a larger screen that can spread those pixels out more, the more pixels you tell the computer to create on your screen, the smaller the text and the graphics will get. Now, you can try to compensate inside your operating system by increasing the size of the text, but it doesn't always work. Now, for presentations or training, as a display device, you could also use a projector. This is a projector here mounted on a ceiling that would project on a wall. You could also get a projector that would sit on a table and would be more portable, and you might have a screen that you bring that's on a stand and you pull down and the projector shines up on the screen. All right, concerning how to connect your display or your monitor to your computer, there's a number of different methods. So first off, there's different types of VGA. VGA stands for Video Graphics Adapter. And VGA, the standard VGA, offers 640 by 480 resolution with 256 colors, and it's an analog technology. It's not digital. So then, stepping up, there's Super VGA. Super VGA offers 800 by 600 with 256 colors, and later it was upgraded to 1024 by 768. Then there's XGA, or Extended Graphics Array. This is 1024 by 768 at 65,000 colors. Now, here's a list of all the different video display resolutions. You can find those at this website here. Now, this over here, this graphic, is a picture of a standard VGA cable. So no matter which one of these up here you're using, you're still going to have a VGA type cable on your monitor that connects to your VGA card. So that's VGA. All right, the next one is DVI, or Digital Video Interface, sometimes called Digital Visual Interface. This is a digital technology, so it replaces the old analog used by VGA, and it's used on all new computers today. It supports much higher resolution, and it goes on up to 1920 by 1200 with a single display, so much higher resolution. And you see the difference in the plug here. That's a DVI plug. All right, then there's HDMI. Now, HDMI is used for high-definition TVs and other digital devices like PlayStation 3 or Xbox, different higher resolution display devices that connect to TVs, commonly TVs or DVD players. So I haven't seen any computers yet today that their standard output goes to HDMI, but I'm sure there's some sort of adapter card you could buy if you wanted to do that. So here's an example of an HDMI cable. It sort of looks like a USB cable, but they are different. And just keep in mind, high definition multimedia interface used for high definition TVs, DVD players, and gaming systems. So that's an HDMI cable. All right, next is S-Video, or Super Video. This is a 7-pin DIN. This is a plug down here. This is what it looks like. Kind of looks like a PS2 mouse or keyboard port. It's analog. It doesn't carry audio on this, and it has a maximum resolution of 480i or 576i resolution. So lower resolution used in the past, but not used as much today. Again, this is a standard for transporting video, but it doesn't carry audio. All right, next up is component, or RGB, which stands for red, green, blue adapter cables. Now, these are analog cables, and they're used to split your video into red, green, and blue, and then you'll commonly have separate audio outputs, like a red and a white for audio. So you see an example of these cables down here. I've also seen them called RCA cables. These are commonly used to transport video and audio, and they're used on older video technology, like hooking your VCR up to your TV. On brand new video technology, you'd use an HDMI cable to do that, and you'd get super high resolution going to a high definition TV. You might use these component cables to hook up an old VCR or a DVD player to an older TV that doesn't support some of these newer technologies. Now, once you have your display, you need to be aware of various video settings. First off, there's dot pitch. The dot pitch of a monitor is the measurement between the subpixels on the screen. Now, this measurement is in millimeters. The smaller the number, the sharper the picture that the monitor provides. So typically when you talk about dot pitch of a CRT monitor, for example, you're talking about, say 0.26. That would be a dot pitch. And the smaller that number gets, like 0.20, the better the dot pitch. There's the refresh rate. This is the number of times per second the display is illuminated. This doesn't apply to LCD monitors. This is just on CRT monitors. There's the response time. This is how long it takes for a pixel on an LCD monitor to get updated. The lower the number, the better the response time. There's the input lag. This is the time it takes for a screen update to be sent from the computer's video card to the monitor. This is measured in milliseconds, and the lower the number, the better off you are. All right, so now let's talk about some input devices. First off, output devices are devices where the user views output from the computer. Examples of output devices are monitors and printers, so you're getting something out of the computer. Now, in comparison, input devices are devices where the user provides input to the computer. So your input is going to the computer, it's going in the computer. Now, examples of this would be a mouse or a keyboard, a barcode reader, a MIDI device like a piano or some other musical device that's hooked up to the computer, you're sending that into the computer. A microphone, you're talking and it's going into the computer. A biometric device like a fingerprint scanner or a touch screen. These are all examples of input devices. All right, the two most common input devices that every computer has are a keyboard and a mouse. So first off, let's talk about a mouse, which is shown over here. There's different types of mice. You have different combinations of buttons on the top of the mouse that you can click. You might have a 2-button mouse, a 3-button mouse. You can have a rolling ball here in the center that you scroll up and down, that scrolls up and down on your screen, or also you can use it to click as a third button. On the bottom of the mouse, how they function, they can have a rolling ball or they can use an LED. An LED is more common today. They're better. They don't get dirty like the older balls do. You can have a PS2 style mouse, which is the end connector over here. We showed you some PS2 connectors earlier on the motherboard in the first video in this series. And PS2 connectors are slowly being phased out and replaced by USB connectors. So this is a USB mouse. You can see the USB connector there. Then you have a keyboard. They call them a QWERTY keyboard because it has the keys here, Q, W, E, R, T, Y, are the first letters from the top left on the keyboard. Now, keyboards today use USB. You see a USB connector down here. And keyboards, keep in mind, are available in different languages and different form factors, meaning like over here, this one has a number keypad. Some keyboards might get rid of the number keypad. You can get keyboards with specialized buttons across the top. You can get wireless keyboards. You can get wireless mice. There's all different sorts of customizations on these two very popular input devices. All right, now let's talk about adapter cards. Commonly, a computer will have an integrated video card, but for higher-end systems that require higher-end video, you can have a separate video adapter. So this is an example here of a video adapter card, and it's commonly just called a video card. Now it can contain a video accelerator to make your video go faster. Most video cards today are either AGP or PCIe, excuse me. Or, like I said, they could be integrated into the system board. You see here, this one is an ATI video card. This is a higher-end video card. It's even got a fan on it. It's such a resource-intensive video card. It generates a lot of heat. It's got to keep itself cool. On the back over here, there is a DVI port to connect a digital monitor using a DVI cable. All right, so that's a video card. Next one is a network interface card, or a NIC. Now, a NIC connects your computer to the network. So you would get an Ethernet NIC, for example, to connect to an Ethernet network. It could be integrated into the system board. This is also called an Ethernet card because Ethernet NICs are so popular. Commonly, you'll have a PCI card like this one. That's what this is here. This is a PCI card slot, and it gives you an RJ45 Ethernet adapter. But you could also get a USB Ethernet adapter or some other form factor of Ethernet adapter like a PC card Ethernet adapter. All right, the next type of adapter card is a modem. A modem is what connects your computer to a dial-up phone line. So a regular phone line in your home or office is used to connect to your modem to dial up somewhere with your computer. Now, these are being used less and less today with the advent of high-speed internet connections like DSL or cable modem. Now, in the past, when people did use modems, and I hate to say that they're completely gone because many companies still have lots of dial-up communication here and there, but it's going away as fast as people can get away from it. Nonetheless, an adapter card modem looks like this right here. This is a PCI card, and on the back here it has analog telephone jacks. So it goes into your computer, and there's analog telephone jacks that plug into your phone lines. Over here on the left, I have a picture of two modems, but these aren't internal modems. They're not adapter card modems, these are external modems. So these connect to your computer with a serial cable off of the back. Just another example of a modem. You can get an internal modem or you can get an external modem. All right, the last adapter card we're going to talk about right now is the sound card. The sound card creates sound out of the computer, and you could have a number of other multimedia interfaces on the sound card. You could have a MIDI port line in to bring in sound. So it's not just the sound that comes out to the speakers. That's primarily what people think of, but it can also do a number of other things that have to do with multimedia. So commonly today, sound cards are being integrated into integrated motherboards, and sound cards don't sell as much today as they used to because they're integrated into the motherboard. But here, this is an example of a sound card. You see the different audio jacks here on the back, and so one would go to your speakers, one might go to your microphone. You might have a line in and a line out. Also, you could have many other types of I/O cards that go into your computer. These are just some of the examples of common adapter cards. So other common adapter cards might be USB cards. They give you more USB ports. On older computers, you might find parallel or serial adapter cards. On servers, you'll have SCSI adapter cards. You can get faxing adapter cards, and the list just goes on and on of all the different adapter cards that are available to go into your computer. All right, so now let's talk about USB ports and cables. Now on a PC, there will be a variety of ports and cables. Proper identification of these ports and cables is critical to the proper usage of the computer. You don't just want to plug in something wherever it might fit. You want to know what you're doing. You want to know what each of these different ports are and the different types of cables you'll need to connect to those ports, and then eventually connect that cable onto the device that you need to use. So now let's take a look at the different types of ports and cables you might find on your computer. The first one we're going to talk about is USB. USB comes in two different flavors. There's USB 1.1 and 2.0. Now 1.1 transfers data up to speeds of 12 megabits per second. USB 2.0 transfers data up to 480 megabits per second. So 2.0 is much faster, and you want to use 2.0 if at all possible. It's the standard on newer computers anyway. Now, USB is commonly used today for just about all connectors except network and video. USB is used for your keyboard, your mouse, your printer, your scanner, your camera, your external disk drives, and much, much more. There's even USB coffee mug warmers, USB aquariums, all sorts of strange USB devices you can hook up to your computer. It's become an amazingly popular technology. Now, there's four different types of USB connectors. There's a type A connector, type B, there's standard mini B, and alternate mini B. So let me show you what these connectors look like. Oh, here we go. All right, the first connector I want to show you is a type A to a mini B. So here on the left, this is a type A USB connector, and when people see this, they commonly recognize that as a USB connector. Technically, it's a type A USB connector. Over on the right, this is a mini B connector. It's still a USB connector, but it's called a mini B. So this cable here, this is what I use to connect my digital camera to my computer to transfer my photos. Over here, this is a type A connector, same type as this one, but it has a type B connector on the other end of the cable. So, for example, this is what I use to connect my bubble jet printer to my laptop so I can print out my digital photos. So that's a type A USB to a type B USB. This is a type A USB to a mini B USB. All right, and then next we have a USB hub. Say that you only have two USB connectors on your computer, but you want to hook up your digital camera, your iPod, and your printer all at the same time. Well, instead of having to, periodically disconnect one and reconnect the other one, you can buy a USB hub, which will give you many more USB ports. So it allows you to expand the number of USB ports you have on your computer. So here's an example of a USB hub. Just a little box that has a number of USB connector ports on each side. This one is a powered USB hub, so it has its own power supply. That's what this little cable is here. So one of these cables goes to the computer to a USB port, and then all of the other USB devices can connect to the USB hub. All right, another type of port or cable is a parallel port. Parallel port may or may not be found on the back of your computer. They've been being replaced with USB for local printer connectivity. Parallel ports were used in the past for printers exclusively. That was how you connected your printer, was almost 99% of the time you would use a parallel port. And a parallel port on the back of the computer was a 25-pin port that looked similar to a 25-pin serial, but was a different gender. And then that was where you would plug this side of the parallel cable, and then this side over here, which was called the Centronics port, would go to a parallel port on the back of the printer, and that was how you would connect your parallel printer. The next one here is a serial port. Now on the back of a computer you might have a serial port, or you might not. Many new computers today don't have serial ports at all. Now in the past these were used to connect modems, and you could have either 9-pin serial ports or 25-pin serial ports. Today serial ports are used to connect to the console port of a Cisco router or switch. So there's still some very, very valid uses for serial ports. Over here, this is an example of a serial port. This is a 9-pin serial port, and this is the end connector of a serial cable. All right, the next one is IEEE 1394 FireWire. IEEE 1394 is better known as FireWire. This supports data transfer rates of 400 megabits per second on up to 800 megabits per second, depending on the version of FireWire. Now this is used for Apple devices and higher-end storage devices. So say I go buy a fancy Sony camcorder. It's a higher-end device. It has its own internal hard drive, and I'm going to record all my video that I use, that I create with a camcorder on the internal hard drive. Then I want to transfer that video from the hard drive to my laptop so I can do some video editing, and then I can burn a DVD. Well, commonly I would use FireWire to do this. And over here on the right you see an example of a FireWire cable. It looks similar to a USB port, but it has a kind of a rounded edge on one side, and the cables don't fit. They're two completely different standards. In fact, they're competing standards. USB really competes with FireWire, but FireWire is really used for higher-end video transfer and storage devices, whereas USB also can be used for that, but it's more standard for all sorts of peripherals, keyboards, mice, whatever it might be. All right, the next cable I want to talk about is RJ45. An RJ45 is a register jack number 45. That's actually the end of the cable right here. This square end that looks like a wide telephone jack has 8 pins, and it's used to connect to the Ethernet network. Commonly today they'll call this a 100 base T Ethernet cable or jack, whatever you want to call it. This is the end. The jack or the receptacle is what this would plug into. So the jack can be considered the male portion. The receptacle would be the female, and then in between the two RJ45s is your cable. And so this could be a cable that goes from your laptop to a switch, or you could have an RJ45 jack on the wall that you plug into. All right, the next type of cable and jack I want to talk about is an RJ11. This is a registered jack number 11. It has 4 pins, and it's a square jack, and you'll recognize this as a telephone jack. This is what you use to go from your telephone to the wall. Now, these are commonly found on the back of a PC or a laptop if they have a built-in modem. So you would use this cable, a common telephone cable, to connect from the modem to your telephone wall outlet. All right, another type of cable and connector is a PS2 keyboard or mouse. Now, PS2 keyboard connectors and mice connectors have been mostly replaced by USB, but it's still important to know what they are and to understand how they're used. And if someone brought you a PC with that on it, you would know what it is. So here on the back of the motherboard, you see an example of a PS2 keyboard and mouse port. Now up here you see examples of the PS2 keyboard, which is on the left. It has a lighter blue color and it plugs into this blue keyboard port. Then there's the mouse, which has a kind of tan or light greenish color, and it plugs into this PS2 mouse port. Next one is infrared. Infrared ports are used for short-range wireless communication. Commonly they're called IR. They have a slow data rate, and they're used to transfer between a PC and a laptop, or a PDA and a printer, or a laptop and a printer, or a laptop and a PDA. They have to be line of sight, so you have to be within the same room and point the devices towards each other. So on the side of this cell phone here, there's a infrared port. On the back of this laptop here, there's an infrared port. It's important to know what they look like. Really, it just looks like a black plastic kind of square on the laptop, but that's where the light comes out of. So think of this like your infrared remote control for your TV. You know, right on the front of it, you have a little black plastic area where the LED light comes out of and creates the infrared signal. All right, the next topic here is cooling systems. Now, all this computing power that we talked about, the CPU, the RAM, the storage, all this generates heat. Now, without proper cooling, computers can easily become overheated. So to prevent this, computers have a fan on the power supply that cools the power supply. But then commonly you'll find multiple case fans. So you might have a fan in the front of the case and in the back of the case to create a flow of air through the case. Then you'll also find fans on top of the CPU and a heat sink on the CPU. So here on the left, you see a fan in the back of the power supply. On the right, here's a fan that's connected to the top of this heat sink. This is a heat sink that allows air to flow through these vents, and the fan pushes that air onto the vents and cools the heat sink, and the heat sink is glued on to the processor. The processor would be down here, the CPU. Now I talked about how there can be a fan on the front of the PC and on the back of the PC to keep the air flowing through the PC. This is an example of one of those fans. So this fan would screw on the inside of the case, but say on the back or the front, and it would be flipped over depending on whether it was on the front or the back of the computer, because you want the airflow to go through the computer in one direction, typically in the front and out the back. And then it has a little power supply cable here that connects onto the computer's power supply or onto the motherboard to get power. Now when installing a heat sink on your CPU, that was what we showed you here just a second ago, there's the big heat sink. When you install that on the CPU, you need to make sure that you use a thermal compound that will conduct the heat from the CPU to the heat sink. So you can't just lay it on there, you can't use Elmer's glue, you have to use a special thermal compound. And wherever they sell those heat sinks, they'll sell a little packet of that thermal compound that you spread across the top of the CPU when you install the heat sink. So just something to keep in mind. Now on the side of extreme cooling, some people are using liquid cooling to cool their computer. So they actually have water flowing through the computer in tubes with a little radiator that's used to cool the computer just like a car. This is pretty scary because water and electricity don't mix. But on the other side of that coin, the more powerful processors and overclocking processors and these powerful video cards, all these components people are putting in into a computer these days really makes the computers get very hot. And water cooling or liquid cooling, it does a great job of cooling those systems down. All right, now Objective 1.2 of the A+ Essentials exam says you should be able to install, configure, optimize, and upgrade personal computer components. This includes being able to add and remove and configure internal and external storage devices, drive preparation including formatting and file systems, install display devices, and add and remove basic input and output and multimedia devices. So to help prepare you for this, I came up with some tasks we're going to perform. The first one is how to add a new internal hard drive. Then we'll talk about configuring display devices and settings and adding and configuring basic input devices. So to show you how to add a new internal hard drive, I'm going to add an internal hard drive to this system I have over here that I can show you. Um, Now at the point that I start showing you, let's pretend I already turned off my computer, I opened the case, I installed my second hard drive, a new hard drive, say I ran out of space on the first one and I want some additional storage. So I'm going to have a different drive letter for that new hard drive, and I'm going to show you how to go into the operating system and just add that new hard drive. All right, so this is my Windows computer over here, and I've added a new hard drive to this computer. I turned it back on, and the first thing I'm going to do is go into the computer management. What I need to do now is to tell the operating system about this hard drive and format it and select a file system and make it available to the operating system. So to do that, I'm going to go into the disk management application, and it actually recognizes that I've got a brand new hard drive installed. It says this wizard helps you initialize new disk and convert the empty basic disk to dynamic disk. So I'll say okay, let's give it a try. It says select one or more disks to initialize. We'll take that default. We'll initialize the new disk 1. I'm assuming that's my brand new hard drive. And it says select one or more disks to convert to dynamic disk. A dynamic disk is an improvement over basic disk in many ways, so I'll take that option. And now it says the wizard will successfully complete the process to initialize and convert this disk number 1. So I'll select finish. And notice down here, see this disk number 1, it says it's a dynamic disk and it has 1,020 megabytes. In fact, the new disk I added is 1 gigabyte. So this disk says it has, it's online, so it's recognized, and it has 1,020 megabytes of unallocated space. You see it also recognizes my disk 0, which is 8 gigabytes. This is my NTFS file system. This is where I booted my computer and I have all my applications. So this is the new disk I added down here. Right now it says that it's unallocated, and if you notice up here, there's only one drive letter. There's C, which actually goes to this disk, but there's no other drive letter for this disk. So it can't be used. If I went into my computer, it wouldn't show up. So what I need to do is I need to format this disk. So I'm going to right click on it and I'm going to say I want to create a new volume, which means I'm going to partition this disk. I'm going to make this a simple disk. I'm going to partition all the space. I'm going to assign the drive letter E. And then I need to select to format the file system. I'm going to take the default and format it with NTFS, and we'll be talking more about NTFS and file systems later in the video series. I'm going to perform a quick format. And it says it's formatting my new disk. It's a dynamic disk. And it's done. So I have my new volume, which is drive E. It's 1 gigabyte or 1,000 megabytes, and it says it's healthy. So that's great news. If I close this out and I go to Start, go to My Computer, here I see my new volume, drive E. If I open that up, it's empty right now inside. I can go over to my drive C, and maybe I have some audio files that are taking up a lot of space that I want to copy. Let's go in and find some files. Let's just pretend that this is an audio file I want to copy. I'm going to copy that. I'm going to go over here to drive E, and I'm going to paste it on there. There we go. So I successfully opened up my disk management application. I used the wizard to initialize my new disk. I created a partition on my disk, and I formatted the disk so it could be used by the operating system. And keep in mind, this was all after I powered down my computer, took the case off, I inserted my new drive, I hooked it up. It might have been a SATA drive or an EIDE drive. Anyway, I hooked it up. I powered the computer back on. The operating system recognized it, and I used the operating system to initialize it, partition it, and format it. All right, so we talked about adding a new internal hard drive. If you were to just add a new USB drive, for example, an external drive, you could plug it in. The operating system should recognize that new USB drive, and then you would have to format the USB drive if it hadn't been formatted already. So now let's look at configuring display drivers and device settings. If I right-click on my desktop and go to Properties, this brings up my display properties. So to configure my display properties, I can go through these different tabs like my theme, my desktop screensaver or background, the different appearance of the boxes or the windows on the screen, the font type, the color, and then I can go into settings. So these things on the left, these first four tabs are more aesthetics. Settings are where you actually configure the resolution. So in this video we learned about the resolution of your screen. Notice I have mine set at 800 by 600. I can increase that all the way up to 1680 by 1050 on my monitor. And I can change the colors over here from 16-bit to 32-bit. I can use multiple monitors. I can go into the advanced settings for my display adapter. And here's where I can configure my dots per inch, my resolution. I can configure my adapter driver. I can tell it the refresh rate of my adapter or of my monitor. I can troubleshoot the monitor and I can use graphics acceleration. And then I can manage the colors of the monitor. So all this is done on the Settings tab of Display Properties. All right, the last task we have is to add and configure basic input devices. Let me show you the Device Manager. That's where you would go in and review your input devices, remove them, or add new input devices. All right, so to go to Device Manager, I'm going to go to Start, Settings, Control Panel, then up to Administrative Tools, and into Computer Management. Before I go in there, take a look over here. Notice that I have settings here I can configure for my mouse. And also in here at some point is keyboard information. Oh, right there, keyboard. They're in alphabetical order. How about that? So here on the mouse I can configure the speed, what the buttons do, the clicking rate, all those different things. But to actually add a device, I would go into either Add Hardware or into Administrative Tools and then into Computer Management and then into the Device Manager. So in the Device Manager, this is where I have information on all my devices and what's recognized by the computer, what isn't, and settings to upgrade the drivers. The drivers are the software that help the computer know how to communicate with the device. So here I have a keyboard input device, tells me what kind of keyboard I have. I have a mouse input device. This actually happens to be a laptop, so I have a touchpad port on my laptop. There might be another or a few more input devices on this computer, but primarily these are the two that you need to be familiar with, which is the keyboard and the mouse. So if I were to plug in, say, another mouse or another type of input device like a tablet, it would show up here in the Device Manager. And I can make sure that the driver was loaded and that the operating system recognized that new input device. All right, so we reviewed how to add a new internal hard drive, how to configure display drivers and device settings, and the basics of adding and configuring basic input devices. And we'll be going into topics like installing and configuring much more in this series of videos. And with that, we've reached the end of our video covering Introduction to PCs Part 2. In this video, we learned about processors or CPUs, memory, display devices, input devices, adapter cards, different types of ports and cables like RS-232 serial, parallel, USB, FireWire. We learned about video display cables like DVI, VGA, HDMI. We talked about cooling systems, internal fans, heat sinks, CPU fans. Then we talked about the basics of installing and removing display devices, storage, and basic input devices. So that's the end of our video, Introduction to PCs Part 2. Thank you very much.